Hi guys, I'm Paul Kahilig, and this is Optimization Word Problem. So over here we have the problem that says, a box with no top will be built by taking a 12-inch by 16-inch sheet of cardboard and cutting it into X number of pieces out of each corner and folding up the sides. Find the value of X that maximizes the volume of the box. So this is very simple. First, we need to illustrate the cardboard sheet in order to further understand the problem. So first, let us draw the cardboard sheet. So assuming that this is a perfect cardboard sheet, over here we have the 16 inches and over here we have the 12. Since we will be cutting out squares out of each corner, let us draw them as well. So all of these squares in the corners are to be perfect. They are supposed to be the same, but for this illustration, since I am not a perfect person, since I am only drawing with my hands, let's just assume that this is perfect. So all of these squares are all the same. So since we do not know their dimensions, let us just label them as X. So over here we have X, and then over here we have X. All these sides are X's, and then since all of these squares are the same, all of their sides are X's. So for the formula of volume, let us write it down. Volume equals length times width times the height. So for our length, we have 16. Since the entire length is 16 and we will be cutting out X, since there are two X's, X plus X is equals to, yes, that's right, you guessed it, 2X. So let us write it down. 16 minus 2X. And then for the entire width as well, we have 12. And since same story, since we will be cutting out X from both sides, we will write 2X. So we have 12 minus 2X. And since this cardboard sheet will be folded upwards, meaning that the X that it will be cut out will also become the side. Since coming from down and then it will be folded upwards, it will become the height. So meaning our height over here is X. So now that we have this, let us multiply all of these. So we distribute them, 16 times 12 and then 16 times negative 2x, and then negative 2x times 12, and then negative 2x times negative 2x. And then we will later multiply this one over here, which is x. So let us do that. 16 times 12 equals 92x. 16 times negative 2x is 32x. Negative 2x times 12 is equals to 24x, and then negative 2x times negative 2x is 4x squared, and then times x. Now we will distribute x to all of these terms, and since we have 32x and 24x, they have the same variable and their variables have the same exponents, we can combine them. So negative 32 plus negative 24 is equals to negative 56. So we have 92x, and then we already know that it's 56, so this is negative 56x squared, and then 4x cubed. Now let us arrange them according to their degree. So 4x cubed minus 56x squared plus 192x. So now we have our volume. For the volume, we will then derive it in order to get a simpler equation, and in order to get the value of our x. So the derivative of the volume, so we have 4x cubed. So 3, by using the power rule, we can derive all of these. So 4x cubed we can make it into 12x squared. 56x squared is 112x, and then 192x is 192 only. Now, in order to find the value of x, we can either factor out and then equate to 0, or we can use the quadratic formula. For this one, we will be using the quadratic formula since 112 and 192 does not have a factor that can will make their number smaller and can be divided by all of them. So let us write down the quadratic formula. So we have negative b plus minus the square root of b squared minus 4ac all over 2a. So now that we have that, let us all substitute the variables for their corresponding numbers. So let us continue to this side. So we have negative b as negative, and then negative 112 plus minus the square root of negative 112 squared, don't forget the parenthesis, then times 4, then 12 as our a, and then 192 as our c, all over 212, because 12 is our a. So since this is very hard to answer by using our mind, let us use our calculator. So for our calculator, as you can see over here, there is the plus minus. It's okay to use the calculator and then solve it in two ways. So first, we can solve it by using the plus sign, and then second, let's use the second. Let us use the minus sign. So we have negative 112, then over here plus the square root of okay, so we now have the answer, which is 7.07. For this one, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. So for this problem, we will be only using 2. Okay, so now that we have that, let us change this sign into the minus sign. So we have 2.26. So right now, there are two answers. There are two values for x. So coming back to this equation, 16 minus 2x times 12 minus 2x times x. This is the formula for the volume. Since there is a physical cardboard sheet, meaning the volume will not be 0 or negative. So for our equation over here, 16 minus 2x, and then 12 minus 2x. So the smaller of these two is 12. So we will be dealing with 12. 12 minus 2x. What will be the possible value of x that will make this whole term 0? Think about it. It's 6, right? Because when 12 minus 2 times 6, the answer is 0. And then when 0 is multiplied by other terms, it will become 0 as well. So meaning 6 is the limit. And also, it cannot be 0. Because if this is 0, and then multiplied by other terms, all of them will become 0 as well. So let us write it down. So x is greater than 0, but less than 6. So what number do we have? What number do we have that is less than 6 but greater than 0? It's 2.26. So right now, let us try to solve for 2.26. So let us use this formula. 16 minus 2 and then use 2.26 as the value of our x. Next, we have 12 minus 2 times 2.26 times 2.26. We have the answer of 194. 194.07, since we have here 194.067 and then we round it off to two decimal places. So we have the answer of 194.07. That is our maximum volume. So over here, this is our maximum volume. This is the highest possible volume that we can reach with the value of x. So meaning that the value of x is 2.26. It is the number that gives us our highest volume for this cardboard sheet with this dimensions. So let us read again the problem. A box with no top will be built by taking a 12-inch by 16-inch sheet of cardboard and cutting it into X number of pieces out of each corner and folding up the sides. Find the value of X that maximizes the volume of the box. So we have here 2.26. So X is equals to 2.26, and then since the problem uses inches, we will use inches as well. So for this problem, this is very simple. It's all about understanding the problem and how to use the proper formula for this. So guys, I hope you understood a single thing about what I just said, because this is very simple and all of this can be solved with the use of our minds. I hope this helps you a lot, because for me it did. So this is Paul Kahilig and this is Optimization Word Problem. Thank you.